Welcome, everyone. Today, we're diving into the thrilling world of IPSec troubleshooting. Because who doesn't love solving mysterious connectivity issues? A stable IPSec tunnel is crucial for secure communication, but problems can pop up unexpectedly. We'll break this down into simple steps, helping you identify and fix common problems efficiently. By the end, you'll have a solid grasp of best practices, ensuring your network stays rock solid and stress-free. I'm Emma Grace, an IAM expert with 10+ years of hands-on experience designing and deploying identity solutions that scale. I specialize in helping organizations implement secure, user-friendly access controls that reduce risk, meet compliance, and support growth without adding complexity. All right, first things first. Before blaming IPSec, let's see if the devices can actually talk to each other. It's like checking if your phone has battery before panicking about missed calls. Start by pinging both ends to confirm connectivity. Verify IP addresses and subnets, because mismatched settings can turn troubleshooting into a guessing game. Also, make sure firewalls aren't playing the villain here. A few quick tests will save you hours of head-scratching later. Now, let's talk about IKE Phase 1, the handshake that starts everything. If your settings don't match, it's like two people talking different languages. Check encryption and authentication parameters across both devices. If logs show negotiation failures, take a deep breath and dig into them. And when all else fails, a good old restart might be just what the doctor ordered. IPSec is picky, but we'll outsmart it. All right, moving on to IKE Phase 2. It's like sealing the deal after a handshake. Tunnel mode settings need to match, or things will get messy fast. Encryption and integrity algorithms should be identical, because mixing them is like expecting coffee and tea to taste the same. Lifetime values must also align, so one side doesn't expire mid-communication. And if you spot mismatches in ESA attributes, well, you've found your culprit. The pre-shared key. A small but mighty detail. If it doesn't match, well, IPSec isn't signing any agreements. Double-check both sides, ensuring there are no rogue spaces or sneaky typos. If things still don't work, just delete and re-enter the key. It's like resetting your password when your brain insists it was right. Let's start with CLI commands, our trusty debugging tool. Think of it as asking the device to spill the beans about what's wrong. First, we check the basics. Is it alive and functioning? Then, we dig deeper using logs and outputs, kind of like reading a machine's diary. If things look suspicious, advanced commands come in handy. And if debugging feels like a chore, automate it. Less typing, more fixing. Logs are like security camera footage. They capture everything. First, scan for obvious errors. Next, timestamps help us rewind to the exact moment disaster struck. But logs can be overwhelming, so filtering out the noise is key. And if staring at endless text lines isn't your idea of fun, log analysis tools can do the heavy lifting. Work smarter, not harder. Packets are the tiny messengers of the internet, and sometimes they get lost or delayed. We capture them to see where they are struggling. First, we inspect them. Are they reaching their destination? If not, headers might be misconfigured. And for the ultimate detective move, we correlate packet captures with logs. It's like matching fingerprints at a crime scene. Dead peer detection. Sounds dramatic, doesn't it? It's like checking if our VPN buddy is still alive. If a peer goes silent, DPD nudges it back into action. Logs help us see what went wrong. Was it a simple timeout or a full-blown network tragedy? Configuring DPD right ensures smooth connectivity, because no one likes a ghosted connection. Proxy ID act like secret handshakes in network communication. If they don't match, devices won't talk. First, verify configuration. Does it align with policies? Then, hunt down mismatches, because even a tiny typo can wreak havoc. A quick modification usually fixes things. So, let's make sure our network handshake is firm and confident. Ping and traceroute are like road trip maps for networks. Ping checks if we can reach our destination, while traceroute shows the route taken. If packets are stuck in traffic, we identify bottlenecks and reroute them efficiently. No one likes network congestion, so let's get those packets cruising. Ever tried fitting a square peg into a round hole? That's what happens with incompatible vendors. First, we check if devices can talk to each other. Then, firmware versions must be aligned. Old software can cause chaos. Supported protocols ensure smooth operation. And troubleshooting helps iron out vendor-specific quirks. Tech harmony is key, and that's a wrap. We've tackled debugging techniques, refined troubleshooting skills, and hopefully laughed a little along the way. Remember, automation is your best friend, and learning never stops in networking. Happy debugging, and may your packets always reach their destination. Please do like, share, and subscribe to our channel.